Hi everyone, and welcome to the channel, and welcome to another episode of Learning FreeCAD for Beginners, teaching the fundamentals of FreeCAD whilst we learn workflows. Today we're looking at a compound workflow to create a threaded container with lid. So we're going to be following on from previous video. We looked at compound workflows before, we understood what they were, and we created a container in there. But in this workflow, we're going to be using a practical example and also going to be creating a 3D printed output of this to show you how effective this workflow is. So I hope you're enjoying this channel, and let's have a look at this technique. If you like what you see and you want to donate to the channel, then you can do so via PayPal at paypal.com/paypalme/Darren B. Stone, or at Coffee via ko-fi.com/MANG0. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/Mango Jelly Solutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. So I've already started a new document in FreeCAD and I'm in the part workbench. We're going to be using a compound workflow. We don't have to use this workflow, but it's a nice follow on from our previous lesson in the Learning FreeCAD series, where we learnt about compounds. So I'm going to show you a compound sketch and how to use that in this workflow. We're going to be sketching one side for a revolve, a profile, using the revolve to create the final shape. For this, I need to come over to the sketcher and start sketching a single sketch. We're looking along the XZ plane. So then create a new sketch along the XZ plane and hit OK. This is the rotation point. So we're going to half what we're looking at, half the container, and sketch one side, the left-hand side in here, and rotate it around here. I've got the auto, remove redundant constraints, auto constraints, and avoid redundant auto constraints all checked. And we're going to use the polyline, this one here. I'm going to start with the lid. So we're going to come across and basically make an L shape. So what I'm going to do to start with, so I can set some dimensions in here with a length, say of 28mm. And now we're looking at the lid height. So this is going to be the lid. Set a height of 12mm. Now we've got the basic dimensions in. This means we can center ourselves and decide where this is going to go. So we can set up our viewpoint. So I want to sketch something like this. So zoomed into the correct scale. Let's use the polyline again. And because we've got the auto constraints on, if I hover over that, we get a coincident constraint. And we're going to come out and create a piece of wall geometry. And we're going to close the sketch. I'm going to hit escape and I'm going to clean up my constraints because this point, it is on that line where it's on the vertical, so that's fine. So I'm going to set some height in here. This is going to be the width of the wall. So we're going to set that. Let's make sure we select this length here because I selected a vertex and an edge, which wasn't any good. Set that to 3mm. And we'll make these two equal. So we've got this here. We've got the length, we've got the height, and we can now set the height of our container with the lid. So I'm going to set this point and set a height in here. This will fully constrain this sketch. I'm going to set this to 60mm. So we have our lid. Now with sketching, we can come out of this and create a new sketch for our body. I'm going to stay in the same sketch. So I'm using a single sketch workflow for this. And this is where the compound sketch comes in and the compounding of objects. So this can create quite a quick workflow. Next, we're going to work on the container. So again, I'm going to use the polyline. And I'm going to think about where the container will sit. So as this screws onto the container, where it will sit. So obviously we need to come in here and leave some room for the threading. So we can come in and come across and down. All the way down, connecting up to this line here. Making sure we have the vertical constraint. We can add it in afterwards. Come across and attach up to that center point, coincident constraint. And we'll make the wall. So coming across and back up. Now at this point, I'm going to do something slightly different. I'm going to come across at an angle. To come right across at an angle like so. And then come up and finally connect up with this point, coincident constraint. Why did I do this? Well, this allows me to 3D print this without the use of supports. So I can set this as a relevant angle to allow me to get this into shape. So it allows me to print from the top, well, from the bottom upwards. Let's get some dimensions in here. So I'm going to take this line and this line and make them equal. Let's look at this from the front. So you can see how this is starting to work its way out now. I'm going to make sure that these 2 points are in line, placing those in line there. And I may place these 2 points in line, place those in line, and we can put some tolerance in here. So I want a little bit of a gap, so this point and this point, and place some gapping in here of 0.5 millimeters, and do the same from these two, so this point and this point, height in here of 0.5. So that keeps these two sketches, well, these two pieces of geometry separate. So we've got this tolerance in here. This can still move in and out. And this is where we place a length between these 2 points using a length. And this is going to be our thread. So I'm going to put 1.5 mil in there. Our thread is going to live in here. Let's finish the model. We need to set some distance here. And I'm going to keep those the same. So take this one and this one, make those equal, 3 millimeters. And we need to set some width as well. To do that, I'm going to take the 3 millimeters between here. So this is 3 millimeters, and take these 2 points and keep them in line. And finally, we can adjust this to the right angle that we know that's safe for 3D printing. Let's place a height in there of 40 millimeters. So what we've got is we have two sets of geometry. So we've got this set here and this set. So two pieces of geometry in here. If I close this, you can see it much more clearly here. So if I click on the front, here's the geometry within here. Let's save this. I'm calling it a compound container. Now here I have a choice. I can create another sketch in here for the threading, or I could add it to the same sketch. Let's add it to the same sketch. So I'm going to come into here and just zoom in. And we're looking at this gap within here. So I'm going to quickly add something in here with the polyline and show you what happens with the workflow. I'm going to add this shape here. So we've got a triangle using the polyline, and I've embedded this into this part of the wall. So I've embedded it into the lid, and it protrudes out in the void between the lid and the wall of our container. Let's hit escape to get the mouse pointer back and place some horizontal constraint. Let's make sure that these two are in line. Vertical constraint, and we'll also make these two equal with each other with equality there. So we've got that there. Now the reasons why these embed into this side, it means when I go to sweep this along a helix, it means it has a great connection with the lid without causing problems when we union these together. Let's take these 2 points, and this line. We can multi-select points and make those 2 points connected with a point on line constraint or point on object constraint with this line here. You can see I've got redundant constraint, which I can click on, number 59, and hit delete. So we've got that one there. Let's set this length with the length constraint to 1.5 millimeters. So this is the start of our thread. So we've got that one there. I'm also going to take this line and create an angle between those. Now the angle's going this way, so let's cancel that and do an angle between this one and this one. Because I really want it going this way. Just makes it a bit easier on the eye. And we'll set that to 60 degrees. So we've got this here. We've got some length going into here, which is fine. And we can set the length up. Just need enough to penetrate the lid. And so that's 0.5. And we've got this one in here all ready to go. So this is the start of our thread. I'm going to do the same on this side as well. Now I could use symmetry to create a symmetric part of the sketch, but I'm just going to sketch this in because it's quite an easy sketch. Let's use the polyline and add the sketch in here. So we can connect up to this line here and come in. It's a slightly different way of doing it. Connect up and then connect up to this point. And then I'm going to make this one and this one equal. Make these two and this one equal. So we've got this now. And what we'll do is just make the ends equal as well. So we've got our two shapes here. And I'm going to come down and make this point and this point, so these 2 points in here, in line with each other. So we have our profile. Now a characteristic of a screw top lid is that the threading itself is not like a normal screw. They don't have as many turns, so we don't need as many turns. And also they don't go all the way to the base. Because if you think about if we have a screw thread in here, then if we don't go all the way to the base, it makes it easy to put the lid on rather than trying to find the screw thread at the base. Also, it doesn't go all the way to the top either. So the top here. We want to have the lid move freely over this thread and make a seal at this point here. So this will seal down. So we can keep on screwing this up and tightening it and having these pressed together to make a nice seal. So we mustn't stop the thread at the top or the bottom. Also, we just need a couple of turns in there. So if I wanted to, I can come in and set some height between these two. Of about 1 millimeter. And we have our thread profile in there ready to go. Now it's all done in one sketch. If I close, we can see that we got the thread profile, the lid, and the container. Now the thing that I've got concerned about is the length between these two. So I want to make sure they don't fuse together if we're 3D printing. So this gap in here. So I'm going to come in and add a point on here, like so. Hit escape. Take these two, keep them in line. And then I can take these two and put a measurement in here, length, and create a reference, so reference measurement. So straight away I see that, well, I don't have enough gappage here. So what I'm going to do is look for this constraint. So I put a horizontal constraint across here, number 76, click on that and delete it. Now I can take this and set this to something like 0.3, make sure the reference is unchecked and hit OK. That gives a gap in there. So we can set up the gap. Another thing that I want to do is create some curvature in here, because if these come to a point, then we've got a chance of this being quite sharp and also a weakness point. It could break off. So I need to create a fillet in here. And I'm going to do this in the sketcher. I'm going to use the filleting tool, but I'm going to use the constraint preserving sketch fillet. This will preserve the sketch constraint that's in here. And it does it by taking, let's fillet this off. So I'm going to click one side and click the other. That will create a fillet between those two. lines will protrude to this point and meet up. And this is the point where we've got the constraint. And that constraint's kept. So we've got this curvature in here. And I can set, say, these 2 points and make sure they're in line. And set, say, a radius on here. And we'll set a radius for this one. So this to 0.25. So something like this. So now we've got our constraint in here, we need to add the constraint over this side as well. So we need to fillet this and constrain it. That's coming to the constraint preserving sketch fillet, add that in. Make these two equal. And looking at this, well, we've lost some constraints in here. So let's Control Z that. Make these two equal. And these two have to be equal as well. So we're all in constraint. Let's hit close. So we have our sketch. So we have our finished sketch, which has multiple closed geometry in here. Now this is a compound. So if I come over to the part and we click on the sketch and come up to part, compound, explode compound, each of those closed geometry will be exploded out into separate sketch parts. So we have this one here, which is the profile, which is the container profile for our thread, and the other one, which is the lid profile for the thread. So lid thread profile. We also got the lid, and we've got the container. So these are all profiles which I'm going to use in either a sweep or a revolve. First of all, let's revolve both the lid profile and the container profile. Control select both of those and use the part, come down to revolve or select it from the toolbar here. Revolving along the Z axis and hit OK, the full 360. So now we've got two revolves, the lid and also the container. Now we've got both of these. Let's hide the container. We can see how these profiles line up. So we can see the lid profile here. Let's hide this one, pressing the spacebar. And now we've got to make the thread in here. To do that, I'm going to use a helix. So let's come up to the view and we'll toggle the axis cross so we can see how that's centered. Let's come up to the part and create the helix from the create primitives. In here we can select from the drop down the helix. Now the helix got a pitch, height and radius. So I'm going to set this for the time being to 28 millimeters. So this was the radius of our container itself. The pitch I'm going to set to double this length here, which was 1.5. So this is going to be 3 millimeters. And we're going to hit create and then hit close. At the moment, this only goes round part the way. So we're going to set the height, press the up arrow until this comes around and basically gives us a crossover here because we don't want too many threads. Otherwise, we'll be continuously trying to unscrew that lid to get to the content. We want this basically a few turns to get inside. So now I've got that. Let's transform this helix. I'm going to hide the lid, pressing the spacebar. And I'm going to transform this up. Right click, transform, and move this up so it looks like it's intersecting that profile there. Let's hit OK. Let's look at it from the side and look at the center. So centering everything on screen. Fit all. And now we can look at this, click on the helix, and just use some placement to get it into position. So I'm going to use the position along the Z axis and just move this up roughly into position. Doesn't have to be exact, we're using the same helix each time. So our threads will be consistent on both sides. Now I've got the helix, let's come over to the part workbench and use the lid profile. Use the sweep or part sweep. So now we've got the sweep, we need to select the lid profile. So let's make sure we get the right profile, lid thread profile, make sure that's selected. Click on the sweep path and click on the path and then click done. Now we need to select this create solid, but if we forget and hit OK, it sweeps. We can always select the sweep and set the solid for this. So come down to the solid, at the moment it's false, I set that to true. So we've got the sweep for the lid, but we're going to see a bit of a problem here. Let's bring back the lid revolve and have a look. And you can see that, well, we've got no lead in or lead out to this thread. So how do we go about solving the lead in and lead out of this thread to make it easier to connect the lid to the container? It's actually quite simple. I'm going to hide the lid, pressing the spacebar, and hide our sweep. Press the spacebar on that. We've got the helix. I'm going to come over to the sketcher and click on this point here. So this vertex of the helix, I'm going to select it and I'm going to create a new sketch. The sketch attachment will be selected to translate in the drop down. If we OK that, so now we've been placed in the center of the sketch with point of the helix at the point of origin. We need to create the lead in and lead out, and it's simply a case with this one of creating a line that connects up to this point and comes out some distance like so. So if I close that, we see that sketch there. If I bring back the lid revolve, you can see that if we follow this revolve, it will be embedded inside this edge here. So we look at the helix, it's the sweep of that helix, pressing the spacebar on that. If we follow this forwards in a straight line, it will get embedded into this lid. So let's do the same on the other side. What we must remember also with a sketch is that we mustn't go too far, otherwise we can come out the other side, but we can just shorten this sketch. You can click on the lid, hide it, and click on the sweep. And press the spacebar to hide that as well. Let's find the other end of the helix and select vertex, create a sketch, translate, and we'll follow the helix around to this point and create a straight line going this way. Now we've got the straight lines in there. Let's close that and connect these up as one single wire. To do that, let's come over to the part workbench and select the sketch, followed by the helix, then followed by the sketch. We do them in order, just in case we hit problems. We're going to use the connect. So in this drop down here, we have our connect objects. This is also available from the part menu, join, and connect objects. You'll normally see the connect objects here, but if it's something else, one of these, then we just change it over. We've created a single wire in here, a single connect. It's actually compound, so we have the wires inside a compound object, and we can see those within there. Now we've got those, let's create our sweep. Let's come over to the left hand side and look for the sweep. So we've got the profiles, lid profile here, lid thread profile, we've got the sweep. At the moment, it's still using the helix, so we need to swap that out. Click the sweep, come down, and you'll find the spine. At the moment, it's helix. Let's click on that, click on the button on the end, and hit clear. and select the new connect object. Once selected, hit OK and click off. And what you'll see is FreeCAD will recompute and add those onto there. But we see that there's a bit of a problem. If we look, you can see we've got this kind of folded face here. This is not a problem. All we have to do is come over to the original sweep and look down and look at our transition. The moment it's right corner, let's drop this down and try rounding corner and click off. We've now got a better connection between those, so you can see how that's connected. Much cleaner there. And if we come back over, let's change that back to the right corner and we can see the difference. You can see we've got that folding in there. Sweep, right corner. Also got transformed as well. And if we look at that, that's even better. So we can juggle between those and decide which one gives us the better transition between those two edges of that connect. Let's bring back the lid revolve, and we're looking good inside, and we can see that sweep follows it all the way into the lid. Now we come to the point where we can merge these two together in a fusion. Click the lid and either control select the sweep from the tree view, or we can control select it from the screen. Come to part, boolean and union. Also available from the toolbar. So let's say your fusion has just failed. So let's cover that scenario. If that's the case, I'm just going to delete this fusion. Then it may be worth creating the sweep in a slightly different way. We still use the sketches and the helix and the other sketch. I'm just going to hide the lid and also hide the sweep. We'll swap that out in a minute. The first thing to do would be to come in to the sketch, and rather than use straight lines, is to use a endpoint and rim point arc. Therefore, we can get some continuity between this edge. Make this less of a straight line coming out. So it's worth doing that. And we can do that on both sides. You can see the sweep is fine there. So we've got sketch 1 to do as well. Let's take away that straight line. Delete that. And create the arc in here with continuity to this edge. So create a tangent constraint on this arc and this axis with tangency, and close that. And we may need to change this one slightly and bring this out. So a look at my sweep, that should have changed. So we've got an arc in here now. We just have a look to make sure they're still okay, and have a look at the lid revolve. So we've got those. So that's one way. And we check the fusion. So the sweep, control click the lid and make a fusion. So you can see those have failed. So that one's failed now. So we've got to that scenario. So that's fixed that. If that's failing, we can make use of something called the curves workbench to connect those together as one single line. So at the moment we've got that connecting there that we're using. This time I'm going to come over to the curves workbench. This is an external workbench, so you'll need to come to tools and add-on manager and search for the curves workbench in here. So click on filters and just type in curves, and you'll find the curves workbench here, not the curve shapes, the curves workbench. If we install that, we can come over to the curves workbench, and there's something called a join curve in here. So this will allow us to join those curves and make continuity against them. So that's coming to the connect. We're going to hide the lid and hide that sweep. So that sweep there, just hide it. and connect up these edges. So I'm going to click on one, control click on the other, and click on this one, and then make the join curve. So we come up to the join curve icon, or the curves, and come down to the join curves. Don't select the sketch helix and the other sketch from the left hand side here using the tree view, because we'll get 3 separate join curves. Now they've been applied, we get this purple edge that goes around here. This is a single edge, single curve. Click on those, press the spacebar. You can see that there. What we can do now is bring back the sweep, come down to the spine where it's got connect. Let's select the join curve this time. Just unselect the connect, just select join curve and hit OK. The sweep has got a tick by it, means it needs recomputing. Edit, refresh, and the sweep has taken. So you can see the sweep has taken. Notice what's different. We've got no edges here now. We've got a nice clean sweep. So now our connect has been separated. We don't need this connect anymore. So we can delete that. And you can see that the join curve is in here. The helix has been released, and the sketch and sketch 2 have been released. And we've just got that join curve that connects up all those edges to sketch 2, edge 1, helix, and the other sketch, edge 1. And now we can come back to the part workbench, bring back the lid revolve, and select the lid, control select the sweep, and do the fusion. And we've got our fusion that's taken in there, and you can see we've got single edges rather than it be separated here with another edge. We need to do the same with the container. So I'm going to hide that fusion, and we need to hide the sketches. And also inside that fusion, we've also got the sweep, and we can see that the join curve is still visible. Now the helix, we still need to keep visible because we're going to do the same on the container. We need to make some modifications to this. Our container, if we look up the container revolve, press the spacebar. We need to get the profile for that container thread. So we've got container thread profile there. Let's press the spacebar. See it sitting there. So we need to make some amendments to our helix, because if we do a sweep with these profiles, let's do that now. Let's do the sweep to show you this. Click the sweep. We need the container thread profile. Double click that. And we need the helix, which is going around the outside. And that's the path. So sweep path. Select the helix. Hit done. Make sure it's a solid, create solid, and hit OK. So you can see that helix is going around there, but we need the lead in and lead out. So to do that, let's hide the container. Again, we're going to select this point. We're coming over to the sketcher. This has got to curve inwards. So this has got to go inwards now. And it's the same routine. Select the vertex, create a sketch, translate, OK. Create our endpoint and rim point arc. We're arcing inwards from this point. And create a tangency constraint against here if you want. And create some arc that goes inwards. Let's close that. And the same on this side, this helix here. That vertex, new sketch, translate, OK, and create the arc that goes inwards. And tangency across those. And close. So we've got those now. We can use the connect, but I'm going to come over to the curves workbench again. and select the first sketch, the helix, the last sketch, and create the join with the join curves. The helix and the sketches are selected at the moment. Let's press the space bar, hide them. And now the sweep, this one here, we can replace the spine. So the spine here is the helix. Click in there, hit clear, and find our join curve, the new join curve, the last one in the list, and hit OK. The sweep was selected as recompute, and that's traveled inwards now. So we can see those traveling inwards. If we have a problem, and you'll see that as a failed sweep, then it's worth coming to the sweep and setting the solid as false. And what will happen if we click off, you might see some odd shaping with this sweep. If that happens, it's just to do with the sketch placement. So I wonder if I can force this to do it. Let's try to force it to do it. It's not going to do it. So if it does, we just need to move our sweep. So those sketches for that sweep. And we just need to position them properly. I don't think it's going to do it. But we can play with these sketches to get the right effect that we want. So I'm going to come over to about here and close that. And you can see it's not solid, because you can see inside that. Let's do the other one and bring this say about here and close that. Once I'm happy, make sure the sweep is set to solid as true. And then we can come into our container. If I come down and find the container, oh, it's at the top. There it is, container revolve. You can see how that's going to go into there. I may do some adjustments on this side. Select the container, control select sweep. Be in the part workbench for this. So we select the container, control select sweep, and create the fusion. And those are fused together. We can hide the join curve. And now we're ready to 3D print this. So to 3D print, we need to export this out. Let's come over to that fusion, just rename that as container. And the other fusion, right click, rename as lid. I'm going to create a link copy. That gives me the choice of how I want to 3D print this. So if I create a link copy with the container and a link copy with the lid, using this link tool at the top, make link, that means that I can use these, transform them and rotate them wherever I want without affecting the main container. So the main container is here. And if I click on link copy, right click transform, you'll notice that I can move this aside. It's like a clone, basically. So that's hide the container, that's hide the lid. Pressing the spacebar on those. We've got our lid here and the container. Click on the container, I can use the placement. I'm just going to set this back to the position of 0. And I'm going to take the lid, right click, transform, and just flip it around this way. And bring it up. And over to the side. So we've got these two. This just gives us an idea of what these look like. We can look over them, rotate them around, see if we got any problems with them. For instance, I can come around and have a look just to make sure everything's okay. I can play with this lid, I can put it on top, I can twist it around, see where it's placed. It's just nice to see those side by side and gives you a way of assembling them and placing them on the screen so we can get an overview of what we're looking at. The link copies can be exported STL. If I lined up the bases of these two, then we could export this as one object by control clicking them and going out to File, Export. But I want to export these out as separate objects. So I can click on the container, go out to File and down to Export and choose what I want to export this as. So I can export this as STL and export it from here and save that out. The same with the lid. Click on the lid, File, Export, and export that out as well. So let's have a look how this 3D prints. Let's have a look at printing this now. As you can see, I'm printing the lid on its own, and we're going to be using basically just the default settings in there. There's nothing special about this. I've just left this with the defaults, gone for a slice, and export it out to the SD card. For the container itself, I reduced the size of it just because I'm running out of PLA. Again, the container is printed with the default settings, nothing special, and the results come out pretty good. The lid on the container screws up tightly. Due to where we place the thread, I use something like a 0.5mm tolerance, but I can reduce that down a bit more. I hope you enjoyed that video, and I hope to see you again in the next one. If you like what you see and you want to donate to the channel, then you can do so via PayPal at paypal.com/paypalme/Darren B. Stone, or at Coffee via ko-fi.com/MANG0. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/Mango Jelly Solutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.